Hello, quick introduction to the video. My name is Cameron. I'm a graduate apprentice software engineer currently studying at Glasgow University, and I'm using this video as a way to sort of rubber ducky debug a LeetCode problem, just to attempt to solve it, and just talk through my thought process, and hopefully it's useful to someone on here. So the problem I'm going to be attempting today is from the LeetCode 150. I'm going to be attempting product of array except self. So I'm just going to read out the question. So, product of array except self. Given an integer array called nums, return an array answer such that each index and answer is equal to the product of all elements of nums except the same index that exists, the value at that index in nums. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. Don't need to worry about that line, I don't think. You must write an algorithm that runs in O of n time and without using the division operation. Okay, so example 1, nums is equal to 1, 2, 3, 4. So whatever goes at this position in output is going to be equal to this times this, I think. So 2 times 3 is 6, 6 times 4 is 24, so that goes here. 12 is going to be equal to 1 times 3 times 4, which is 12. Whatever goes here is going to be equal to 1 times 2 times 4, which is 8. And then whatever goes here is going to be 1 times 2 times 3, which is 6. Okay. So, constraints, the length of numbers is between 2 and 10 to the power 5. Don't think we need to worry about that. And each number is between minus 30 and 30. Again, I don't think I need to worry about that. So, switching over to my notes, I'm just going to come up with a way to do this. So, we got, let's say nums is equal to 2, 3, 4. We do 2, 3, 5, 4. The only problem I can foresee is that it has to be O of n. We're gonna have to have like an output that has to have like the same amount of slots as nums, so 4. Has 4 slots, or has n slots, n being the amount of nums. Okay, so the first way that came to my head was you would go to each number, you would go to here, and then you would times 3 times 5 times 4. Then you go to here, then do 2 times 5 times 4. Then you go here, do 2 times 3 times 4. Then you go here and do 2 times 3 times 5. But I mean, I'm not an expert on time complexity. It's not something that I'm great, like that kind of algorithm analysis or whatever you want to call it. It's not something that I'm particularly like proficient in. It's something that's quite new to me. So I think if I was to do it that way, that would be of n squared time complexity, because you're kind of looping over each item twice, because you're looping over 2, then 3, then 5, then 4. But then you're also, for each of those iterations, you're also looping over the entire list except from the one that you're currently on again. So yeah, it's a bit complicated. I'll maybe just start off an O of n squared solution and see if I can get it down any lower. So let's see, ideas. We could have output with each slot being like 1, I guess. So it could be like output is equal to, let's go 1 times 1, 1, 1, 1. Then you could do, like, for this first slot, you could do 1 times 3, and then whatever's in there times 5, and then times 4. So for instance, you could loop through and times all of these by 2 except from the first one, then go to here, times all of these by 3 except from this one, all of them by 5 except from this one, all of them by 4 except from this one. I don't know if that'll be O(n) or O(n) squared. O(n) squared. I'm gonna attempt it, and then if need be, then I can maybe attempt this either at a later stage, where I've learned, you know, other tools to help me solve these types of problems, or I can try and get it from n squared down to O of n somehow. So I think the general gist is iterate over each number in nums, multiply each of the output slots by current num apart from slot output I. And then we're going to return output. So let's try this. Going to switch over to here. And what I usually just copy and paste my notes in and comment them out. So, iterate each number and, well, we need an output first. Output is equal to 1 times the length of nums. Okay. I'm just going to print output to make sure I've done this right. Yep, okay. So we've got 1, 1, 1, 1. And then for num and nums. Oh, for num and range length of nums. For each num, we're gonna So for each num and range, you're gonna loop over for slot and output. For slot and range output, if slot, which is going to be like 0, 1, 2, or 3, if slot is equal to num, continue, else output slot times equals nums num. Does that make sense? Return output. I think this is O(n) squared though, because you're looping over each of them n times. For slot and range length of output. Run. So these two got accepted. I'm going to submit this, but I reckon that this is going to get a TLE, this is going to get failed, because I'm almost certain this is O(n) squared. Come on. Please. I think this is going to be TLE. Yes. No. Right, okay. So it got through almost all of the test cases. That's really annoying. Let's use this test case. That's up a lot of numbers. Oh, actually, I'm printing out that is a lot of numbers. Maybe it's all of this print statement that's taking it all up. That's using up all the resources. Doesn't look like this test result's taking time limit exceeded. That is really annoying. Okay, back to the drawing board, I guess then. The only other option, well, the annoying thing is you can't even use a division operation, because the other way that I'd sort of thought was, you could take the, what do you call it? You could take the product of all of them. So you could do like, you could do product is equal to, initialize it to 1, and then for num and nums, product times equals num, and then you do print num print product. So the product would be like 1 times 2 times 3 times 4, right? Oh, you can't multiply sequence by non, what? What was this on about? Oh, num, not nums, sorry. So we get 24 because 1 times 2 times 3 times 4 is 24. For here we get 0 for some reason. Negative 1 times 1 is 1. No, negative 1 times 1 is negative 1. Negative 1 times 1, still negative 1. Negative 1 times 0 is 0. 0 times negative 3 is 3. And then 3 times 0 is 0. So that's why you get that. So that wouldn't even work. You can't even find the product of all of them. That is a tricky one if there's zeros in it. That's a real tricky one. Honestly, I'm lost for solutions here. Without iterating over it twice or to get, because if you're at this index, right, you're index 0, and you want to find out what output 0 should be, you're gonna have to do this times this times this, right? I mean, you could take 1 times 2 times 3 times 4 and then divide it by 1, which would give you 24. Then you could go to here, get the product, which would be 24. Do 24 divided by 2, 12, which is right, because 1 times 3 times 4 is 12. Same with here. At index 3, or index 2, you've got 3. 24 divided by 3 is 8. Yeah, it's 8, right? Yeah. Which is correct. And then same for the last one. 24 divided by 4 is 6, which is the right answer. So it is, it's a bit tricky. I'm honestly very tempted to go to the discussion board, because with these the initial idea was to just attempt them without looking at any hints or anything, but you know, I'm genuinely I'm stuck here. I have no other option. You know, looking at the follow-up here as well, it kind of to me seems like it's asking you, well, it's suggesting that the easier solution would require some other data structure, because it says follow up, can you solve it in ov1 extra space complexity? The output array does not count as extra space for space complexity analysis. So yeah, it's a bit difficult. I think what I'm probably going to do is leave this for now and come back to it at some later point in the LeetCode 150 once I've had a better look at some of the other tools that I could use to solve this. So thank you very much for watching, and if this was useful to you in any way, please let me know, or if you had any other sort of hints or suggestions that you could have that you could give me that would maybe point me in the right direction, that would be greatly appreciated. But yeah, thank you once again for watching the video, and I hope you have a great day.